Welcome back. Let's look at question number 5. Question number 5, you are given the circle C1 has equation x squared plus y squared minus 6x plus 5y minus 41 equals to 0. Part A, find Roman 1 the coordinates of the center of C1, and Roman 2 the radius of C1. Let's start with the part A. So here's the equation. Here's the equation. Part A equals Roman 1. The equation you are given as x squared plus y squared minus 6x plus 5y minus 41 equals to 0. We can rearrange this equation so that we'll have x squared minus 6x plus y squared plus 5y minus 41 equals to 0. Now for us to get the coordinates of the center and the radius of the circle C1, we can use either completing square method or we can use the formula, and today I will want to use the formula. The coordinates of the center, we can have center of C1 is we'll have negative h over 2, negative k over 2. We can clarify here where h is simply equals to the coefficient of x, which is negative 6, and k equals to the coefficient of y, which is 5. Now once we substitute this back into the formula, then we'll have center of C1 will be bracket negative 6 over 2 comma negative 5 over 2 comma. Simplifying this, we'll say that center of C1 is given by the coordinates. Simplifying, you'll have this as 3 comma negative 5 over 2. We can also find the radius of C1. So Roman 2 here, radius of circle center. Circle is called C1. Radius will be given by, we can have the formula r equals to the square root of h over 2 square plus k over 2 square minus c. Now on the same note, h is simply equals to the coefficient of x, which is simply negative 6, and k equals to the coefficient of y, which is 5, and c is the constant, and the constant here is negative 41. Now when we substitute this back into the formula, we can have the radius will be equals to the square root of negative 6 over 2 square plus 5 over 2 square minus negative 41. And when this is simplified, we'll have key the whole of this in the calculator. We're going to have the root of negative 6 over 2 square plus 5 over 2 square. Of course, this one is going to be plus 41. So we'll have the radius here to be 15 over 2. So that is part A, Roman 1 and 2. Let's proceed to part B. Part B, going back to the question, says the circle C2 has center negative K0, where K is a positive constant, radius 5. Given that the circle C1 and C2 touch, find the exact value of K. Now, just to sketch what we've been given, we have two circles, circle center C1 and another circle center C2. Circle center C1, just to sketch it well, and another circle C2. So we can call this one C1 and C2. We have the center of C1 given as 3, negative 5 over 2. Join a line to join C2, the circle of C2. The coordinates of the center is given as negative K0. And remember, we are given both the radius, the radii. First, we are given as 15 over 2 as the radius of circle C1, and 5 as the radius of the circle C2. Now the question wants us to get the value of K, and remember K is a positive constant. So this is what we're going to do. For us to get the value of K, then it means we have to get the distance between the circle C1 and the circle C2. Of course, we are considering the center. So if you look at this, we'll use this using the formula for getting the length or modulus. And we always know that the length of between 2 points is given as the square root x1 minus x2 square plus y1 minus y2 square. But you see, this length is what we have as 15 over 2 plus 5. Now, when we substitute the values of x1, x2, y1, and y2, this is what we are going to have. We'll have 3 plus k, we square, then plus negative 5 over 2, we square, then we can get the square root, and this one is equivalent to 15 over 2 plus 5. Simplifying this, we'll have of course we can get the square root at we can get rid of the square root at this point, by squaring both sides. We can square this side and also square this side. So that we have this one will be k plus 3 square plus simplifying this is the same as 25 over 4, and this one should be equals to 5 plus 15 over 2 we square. So taking 25 over 4 the other side of the equal sign, this is what we're going to have. We'll have k plus 3 square equals to 5 plus 15 over 2 square minus 25 over 4. So we can use the calculator here. We'll have 5 plus 15 over 2 square, then minus 25 over 4, and your solution here is 150. So this means that we'll have k plus 3 square equals to 150. We can get the square root of both sides, so that we only remain with k plus 3 equals to root 150. Now 150 can also be written as maybe if I use a different pen, 150, the square root of 150 can be written as the square root of 25 times 6. And you see this one can be simplified as 5 root 6. So once we replace this, this is what we're going to have. K plus 3 will be equals to 5 root 6. Taking 3 the other side of the equal sign, k will be equals to 5 root 6 minus 3. And this is the value of k.